Hello, students and friends. Welcome to yet another episode on our online tutorial on Prep Station. Today, we'll be looking at the topic circular motion. So, what is circular motion? Circular motion is defined as the motion of an object around a circular path. So, when an object is said to undergo circular motion, is when it moves around a circular path. So, when is the object said to undergo a uniform circular motion? It does that when it is moving along the circular path at a constant speed. So once the speed is using to move around the circular path is constant, we can now say that is undergoing uniform circular motion. Now there are a few components of circular motion that we need to understand. Number one is the changing velocity. Because it is moving around the circular path, the direction keeps changing, and so the velocity also changes. Then we want to talk about the centripetal acceleration. And this is the acceleration which is usually directed towards the center of the circle. You understand? So now, the formula for centripetal acceleration is given as A is equals to V squared over R. V is your linear velocity, while R is the radius of the circular path. So, the next thing we talk about is what you call centripetal force, F. That is the force that keeps the body along that path. And it's also given as M is equals to V squared all over R. That is the product of the mass multiplied by the acceleration, which gives F is equals to M V squared over R. Now, let's take a look at some of the past questions under circular motion and see how we can solve. First, a force F is required to keep 5 kilogram mass moving around a circle of radius 3.5 meters at the rate of 7 meters per second. What is the speed if the force is tripled? So if you look at this question, they are asking us for force. So first of all, we are going to calculate the centripetal force, and that is the force that is acting on an object that is undergoing circular motion. And we remember the formula for centripetal force is given as mv squared all over r. mv squared all over r. Now, from the first part of the question, the mass that is given here is what? 5 kilograms. 5 kilograms. And the radius we are talking about is 3.5 meters, while the velocity of motion there is 7 meters per second. So if you substitute these parameters into the equation mv squared over r, you're going to have 5 multiplied by 7 squared all over 3.5 square. Now, after rightfully substituting these figures, you will notice that your answer is 70 newtons. But that is not the answer to the question yet, because we are asked to calculate the speed if the force is tripled. So if our force is at 70 newtons, when it is tripled, it is going to be 70 multiplied by 3, which will give you 210 newtons. 70 multiplied by 3 will give you 210 newtons. Now, if we go back to the equation, which says F is equals to mv squared over r, in this case now we are looking for V, and so our F now is going to be 210, while our R is 3.5 and our M is 5 kilograms. Now after substituting this, we are going to have V will give us square root of FR all over M, which will be equal to square root of 210 multiplied by 3.5 divided by 5, everything inside the square root. And if you look at the answer you will get 12.1 meters per second. So let's go back to the options that we have there. The first option say A is 4.0 meters per second, B 6.6 meters per second, C 12.1 meters per second, and D reads 21.0 meters per second. So from there we can see that the right option to that question is C, 12.1 meters per second. So that is the solution to that question. Now let's still take another question, still on circular motion. A particle in circular motion performs 30 oscillations in 6 seconds. What is its angular velocity? A particle in circular motion performs 30 oscillations in 6 seconds. what it is angular velocity. The first option A, there is 10 pi radians per second. B reads 5 pi radians per second. C, 6 radians per second. And then D, 5 radians per second. So now, what is the formula for angular velocity? Angular velocity is given as 2 pi multiplied by your frequency. And how do you get your frequency? Your frequency is the number of oscillations divided by the time taken. So if you do that, you have 30 oscillations divided by what? 6 seconds. So you have 5 hertz. So if you substitute for angular velocity, which is equals to 2 pi f, you are going to have 2 pi multiplied by your frequency, which is 5. So the answer there is 2 pi. So the answer to that question is what? 10 pi radians. 2 multiplied by 5 will give you 10 pi. So the answer to that question is option A, which is 10 pi radians. Now, let us take another question still. It's a particle of mass 10 raised to power minus 2 kilograms is fixed to the tip of a fan blade, which rotates with an angular velocity of 100 radians per second. If the radius of the blade is 0.2 meters, calculate the centripetal force. So here we are required to calculate centripetal force. And we all know that the formula for centripetal force, as earlier stated, is m multiplied by the square of the velocity, all divided by the radius. So now, let us look at the question and pick out a few parameters that are given. Number one, the mass was given as 10 raised to power minus 2 kilograms, while the angular velocity, omega, is given as 10 radians per second, while the distance, which is the radius, is given as 0.2 meters. So if we substitute all these parameters into our equation, F is equals to mv squared over r, we are going to have 0.1, 0.01, that is 10 raised to power minus 2, multiplied by the square of the velocity divided by 0.2. So if we do all that very well, we are going to have F is equal to 0.1 multiplied by 20 divided by 0.2. Now, that will give us 20 newtons. But before we got 20, let us look at it deeply, because we needed to calculate for our velocity first. So our velocity is given as angular velocity multiplied by the radius. So that will be 100 radians per second multiplied by 0.2, which gives you 20 meters per second. So that's how we're able to get the value for our velocity, which we substituted into the equation for centripetal force, mv squared all over r. Thank you.